In Unit 2, Section 11 here, we're going to be solving and graphing, for that matter, compound inequalities. Well, what is a compound inequality? Well, basically it's two inequalities in one problem. And there are two kinds of compound inequalities. There's a compound and a compound or. Now for a compound and, when you're graphing a compound and, I'd like for you to use three number lines, because here's what a typical answer would look like for a compound and. You may have an open circle here, and we're shading everything to the right. And then you may have a filled in circle here, and we're going to be shading everything to the left. Well, that breaks the graph up into three sections. And what I want to know is, where is this graphed on both of the number lines? Where do they overlap each other? Well, they don't overlap out here to the left of that dotted line. They don't overlap here because this is hollow. If this is hollow, it'll be hollow here. They don't overlap out here, but they do overlap on this point right here, so I'm going to fill that in. They also overlap in between the two, so I'm going to shade in between the two circles. And that's what a typical, not all of them by any stretch of the imagination, but that's what a typical compound and would look like. For a compound or, all you need to think about is graphing a compound or is graph both inequalities on one number line. So a typical, and again, this is typical, not by any stretch, going to take care of all compound ors, but this would be a typical compound or would look like this. Perhaps a hollow circle and shade to the left, and maybe even a hollow circle and shade to the right. But the point being, for a compound or, typically they will look like oars of a boat, if you will. They both point out. All right, so let's graph number one. X is less than 8 and x is greater than -3. While we're doing this, think about a number that is both less than 8 and at the same time greater than -3. And the operative word here is and. Typically, what we want to do for a compound and is make three number lines, one on top of the other, and all three of them will be labeled the same way. Obviously, the -3 is to the left of the +8 over here. Now, on the top number line, you're going to graph x is less than 8. How does that look? Well, it'll be an open circle on the 8, and we shade everything to the left. On the next number line, we're going to graph the other inequality. X is greater than -3. What do we do there? Hollow circle on -3, shade everything to the right. Now, where is it these overlap? Well, it's open at -3, it's open at 8, but it is shaded everywhere in between, and this is the actual answer, the bottom one, everything from -3 to 8 exclusive. In number 2, I want to know a number that is either greater than 4 or less than or equal to -2. Give me a number that is greater than 4 or less than or equal to -2. To graph this inequality, all it takes is one number line. The -2 will be to the left of the 4. So we graph x is greater than 4 by putting a hollow circle on 4 and shade everything to the right. and we put in a filled in circle on -2 and shade everything to the left, and any number in the shaded area would work, would solve this compound inequality. Now number 3, -2 is less than x is less than or equal to 5. This is a compound and. It will take 3 number lines. Now notice that we have one inequality here. X is less than or equal to 5. But also notice we have another inequality here, and that's -2 is less than x. But when I graph, I want the x on which side? On the left side. So what I have to do is take this inequality and flip the whole thing over if I'm going to graph it. X is greater than -2. So these two are the two inequalities I want to put on my number lines. It's a compound and, so it takes 3 number lines. The -2 will be on the left side. The 5 will be on the right side. And if we were to graph x is greater than -2, and again, look at the original problem and see how we came up with x is greater than -2. It'll be a hollow circle at -2 and shade everything to the right. Less than or equal to 5 will be a filled in circle at 5, shade everything to the left. Now the answer comes from where these two overlap. They don't overlap at -2. They will have a hollow circle at -2, so we'll have a hollow circle in the answer. We have a filled in circle at 5, so I'm going to fill it in. They also overlap in between the two numbers, so I'm going to shade in between the two numbers. So a hollow circle at -2, filled in at 5, shaded everywhere in between. In number 1 here at the bottom, what I'm going to need to do is take each of these and solve them. So I'm going to add 2 to both sides here, and I get n is greater than -1. Now this is a compound and. Subtract 4 from both sides here, and I get n is less than 2. Being a compound and, I want 3 number lines. Do you have to put in 3 number lines? No, but it would be a good idea to. Obviously, -1 to the left, 2 to the right. Graphing n is greater than -1 would be a hollow circle at -1, shade to the right. Less than 2 would be a hollow circle at shade to the left. Hollow at -1, hollow at -2, shaded in between. In number 2, subtract 2 from both sides. X is less than -7. Subtract 2 from both sides. X is greater than 3. Being a compound or, we only need 1 number line here. Obviously, the -7 to the left, 3 to the right. X is less than -7 is a hollow circle at -7, shade to the left. Hollow circle at 3, shade to the right. And we're done. Here's your OR. You have 2 inequalities. So subtract 1 from both sides here. You have -3p is less than or equal to -12. Now notice you're going to be dividing by -3 here. So what happens to the inequality sign? It gets reversed, and we have p is greater than or equal to 4, or p is less than 2. Being a compound or, we only need 1 number line. Your 2 would be on the left side, the 4 on the right. Greater than or equal to 4 would be filled in on the 4, shade to the right. Less than 2 is a hollow circle on 2, shade to the left. Now look at number 4. We have x minus 3 is less than 6x plus 2 is less than or equal to 2x plus 32. Looks complicated, but let's dissect this thing and see what we're really having here. That inequality sign right there gives us this inequality over here. X minus 3 is less than 6x plus 2. So let's write that one down. But also notice that this inequality here gives us this inequality here. 6x plus 2 is less than or equal to 2x plus 32. Let's write that down. Now notice what happened here is that the 6x plus 2, the part that's in between the two inequality signs, gets written here. Let's take that out. The 6x plus 2 gets written here in this inequality. The 6x plus 2 is also here in this inequality. We actually have two inequalities written here. Let's look at it again. Here's one of your inequalities, and that's what we wrote here. Here's the other inequality, and that's what we wrote here. So make sure you're paying attention to that when we do these. And because this is written the way it is, this is a what? Compound and. So let's solve this. I'm going to subtract 6x from both sides because I want my variable on the left side. So I have negative 5x minus 3 is less than 2. Add 3 to both sides. Negative 5x is less than 5. Dividing both sides by a negative reverses the inequality sign. X is greater than negative 1. Subtracting 2x from both sides here. I have 4x plus 2 is less than or equal to 32. Subtract 2 from both sides, you get 4x is less than or equal to 30. And since we're graphing, usually I want mixed numbers or improper fractions here. But since we're graphing, we can use mixed numbers or even decimals if you like. X is less than or equal to 7.5. So since this is a compound and, 3 number lines. All labeled the same. Negative 1 on the left, 7.5 on the right. How would you graph greater than negative 1? Hollow circle at negative 1, shade to the right. Less than or equal to 7.5 would be filled in at 7.5, shade to the left. Where do they overlap? Well, it's hollow at negative 1, filled in at 7.5, and shaded in between. In number 5, this is a compound door. We're only going to need one number line. We put them both on the same number line, we'll be done. So I subtract 4 from both sides here, and I get x is less than 1. When I add 1 to both sides here, I get 8 is greater than 2x. Dividing both sides by 2, I get 4 is greater than x. But remember, in order to graph, I want the x on the left side. So I'm going to flip this whole thing over, and it's going to read x is less than 4. One number line. 1 to the left, 4 to the right. Now when I graph x is less than 1, Hollow at 1, shade to the left. Now here's where you have to ignore what you did before with the x is less than 1. Remember, the rule is to put both of these inequalities on the same number line. So I need to put x is less than 4 on this number line. What does that look like? It'll be a hollow circle at 4 and shade everything to the left. So what happens at 1? It gets filled in. So we keep going, and it'll be everything less than 4 is the answer for number 5 here. In number 6, again, we have this compound inequality. It's a compound and. Now, we've got to be careful on this one. Now, remember what we did above. Here's this inequality, the less than, right? So we take all of this and write it down. 3x plus 6 is less than 4x. And what do we do then? Well, we take this inequality and everything after it gets written down. 4x is less than x plus 2. So this 4x that's in the middle goes with both inequalities, just like the problem above where we had the 6x plus 2 in the middle. It went with both inequalities. So will the 4x go with both inequalities. Now, usually I want to subtract cancel out anyway, the variable on the right side. I would usually want to cancel out the 4x on the right side. But when that happens, you get 0. We don't want to do that. So subtracting 3x from both sides, I get 6 is less than x. Because we're graphing, let's flip it over. X is greater than 6. In the second inequality, I'm going to subtract x from both sides. 3x is less than 2. Dividing both sides by 3, it's not 1.5. It's x is less than 2/3. So 3 number lines. This is a compound and. So 3 number lines. Be careful on this one. Don't be thinking that we're going to shade between the 2/3 and the 6. 2/3 to the left, 6 to the right. How do you graph? X is greater than 6, hollow at 6 and shade to the right. How do you graph? X is less than 2/3. It's a hollow circle at 2/3 and you shade to the left. Now, my question on this one is, where do they overlap? Well, they're not both shaded here. They're not both shaded in the circles. They're not both shaded in between the numbers. This circle, they're not both shaded in. They're not both shaded over here. So where do they overlap? They don't. There's no number, so we put no solution on the number line. And there is no number that is greater than 6 and at the same time less than 2/3. In the last set of problems, we need to write compound inequalities for each of the graphs that are given. In number 1, you have a compound and here. How do you know? Because the shading is in between the 2 points. That's a good indication that we have a compound and. Well, ignore all of the stuff from the 3 to the right. In other words, just look at that. What compound inequality would have a filled-in circle at -5 and be shading to the right? That's right, it's x is greater than or equal to -5. At the same time, what inequality would be a hollow circle at 3 and shade to the left? X is less than +3. So this would be the compound inequality that we would need to write for the graph that's given there. Number 2, what kind of compound inequality is this? Because the 2 arrows are pointing outward like oars on a boat, this would be a compound or. Well, what is this inequality? Well, it's x is less than or equal to negative 1. And what inequality is this? It's x is greater than or equal to 4, and this is the compound inequality for that graph. Number 3, we have another compound and because of the shading in between the 2 points. We have x is greater than or equal to 0, and x is less than or equal to 9. And in number 4, we have another compound and. We have x is greater than or equal to negative 2.5, and we have x is less than 7. And that concludes the lesson on graphing compound inequalities.